Have you ever looked up at the night sky and felt a sense of smallness? A feeling that we are just a tiny part of a vast, untamable cosmic ocean. For all of our incredible advancements, for all the knowledge we've gathered, there are still questions that leave even the most brilliant scientific minds utterly stumped. What is the universe really made of? Are we truly alone in this seemingly infinite expanse? And what is the very nature of consciousness itself? That spark within each of us that allows us to ask these questions in the first place. Hi, welcome to Spectrum Analyses. Today we will be talking about top 10 greatest unsolved mysteries in science. So first up is the nature of the human mind. The nature of the human mind has been a subject of profound philosophical debate for centuries. Before delving into its intricate aspects, it's crucial to establish a foundational understanding of what the mind truly is. Often considered distinct from the purely physical world, the mind is broadly understood as the seat of consciousness, thought, perception, and feeling. It acts as the primary interface, translating the external world into the internal experience and understanding of an individual's surroundings. Intriguingly, this exploration inevitably leads to the concept of consciousness, a profound mystery in itself. With the emergence of consciousness, the ego is born. Here, ego refers not to arrogance, but to the realization of self, a state where an individual acknowledges their own existence. This self-awareness, in turn, often prompts a deeper inquiry into the very nature of one's being. The ego, therefore, is the very foundation upon which our sense of individual identity and selfhood is constructed. Anything lacking this self-awareness is typically considered unconscious and, by extension, without a mind in this specific context. This then raises the fundamental question: is the mind merely consciousness, or is it inextricably linked with, or perhaps even a product of, the ego? Second is the unified theory of physics. The unified theory of physics, often called the theory of everything, represents humanity's ambitious quest to uncover a single, elegant framework that can describe all fundamental forces of nature: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, and all elementary particles, essentially explaining everything from the cosmos to quantum mechanics. While classical physics successfully described gravity, Einstein's general relativity, and unified electricity and magnetism, Maxwell and the electroweak theory later combined electromagnetism with the weak force, a significant challenge remains: reconciling general relativity with quantum mechanics. These two highly successful theories operate on fundamentally different principles, making their unification notoriously difficult. Current leading contenders for this grand theory include string theory and M theory, which proposes that the universe's basic building blocks are tiny vibrating strings rather than point-like particles, and loop quantum gravity, which seeks to quantize space-time itself. Despite the immense intellectual challenge and the need for energies far beyond current experimental capabilities, the pursuit of a unified theory continues, driven by the promise of answering the universe's deepest mysteries, from the Big Bang to the nature of dark matter and energy, ultimately offering a more complete and beautiful understanding of reality. The unified theory of physics, often called the theory of everything, represents humanity's ambitious quest to uncover a single, elegant framework that can describe all fundamental forces of nature: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, and all elementary particles, essentially explaining everything from the cosmos to quantum mechanics. Next up on number 3 is cell suicide. In the intricate ballet of life, even cells, the very building blocks of our existence, perform a dramatic act, self-sacrifice. Far from a tragic flaw, this cell suicide, primarily through a meticulously choreographed process called apoptosis, is a heroic feat vital for our survival. Imagine it as a cellular cleanup crew, diligently removing worn-out parts to make way for the new, ensuring our tissues stay pristine and functional. During the sculpting of our very bodies in the womb, this cellular self-destruction carves out our fingers and toes, shaping us from a formless mass into distinct individuals. It's our internal police force too, swiftly eliminating rogue cells damaged by stress, toxins, or even potential cancerous mutations, thereby safeguarding us from disease. When invaders strike, infected cells bravely choose to die, sacrificing themselves to halt the spread of pathogens, acting as silent sentinels protecting the wider community of cells. This elegant, essential process, orchestrated by specialized enzymes, ensures the continuous renewal, perfect development, and robust defense of every living organism, proving that sometimes, in the grand scheme of life, an ending is truly a beautiful beginning. On number 4 is the Big Bang. Imagine everything we know, every star, every galaxy, every particle of matter, condensed into a point smaller than an atom. That's where our universe's grand story, the Big Bang, begins. In an instant, this cosmic seed unfurled, not with a bang, but as an astonishing expansion of space itself. As it ballooned outwards, it cooled, forging the fundamental forces and giving birth to protons, neutrons, and electrons. Within minutes, the lightest elements like hydrogen and helium were formed, and after 380,000 years, light could finally travel freely. This left behind the faint glow we now detect as the cosmic microwave background, a direct echo of creation. From this cosmic soup, gravity gathered atoms into the first stars and galaxies, building the breathtaking universe we inhabit today. But what came before that initial spark? That's the ultimate cosmic mystery. Was it another universe collapsing, part of a vast multiverse, or did it emerge from a quantum whisper? While the Big Bang charts our universe's journey, the question of its ultimate origin remains the most captivating frontier of scientific inquiry. On number 5 is time. Time moves in only one direction, from the past to the future. And this isn't just how we perceive it. It's a fundamental aspect of the universe, largely explained by the second law of thermodynamics. Imagine a dropped glass shattering or cream swirling into coffee. These events never spontaneously reverse. This is because everything in the universe naturally tends towards increasing disorder or entropy. The universe started in a highly ordered, low-entropy state with the Big Bang and has been expanding and becoming more disordered ever since, creating a cosmic arrow of time. Our own memories flow in this direction too, as forming and recalling them are physical processes that contribute to this increasing disorder. So, while the tiny particles making up everything might not care which way time flows, the collective behavior of countless particles ensures that the universe and everything within it is constantly moving towards greater randomness, giving time its unmistakable forward-only trajectory. It's 6th. we're diving into the mystery of black holes. Imagine a cosmic abyss so profound, it warps the very fabric of space-time. A region where gravity reigns supreme, swallowing everything, even light itself. This is the enigmatic black hole. Not a literal hole, but a super-dense remnant of a collapsed massive star, or a colossal entity lurking at the heart of galaxies. Formed when gargantuan stars exhaust their fuel and implode, or emerging as supermassive giants from the early universe's cosmic mists. These celestial devourers are defined by their event horizon, the ultimate point of no return. We can't see them directly, but we witness their insatiable appetite as they heat nearby gas into glowing accretion disks, stretch matter into cosmic spaghetti, and twist distant starlight, even shaking the universe with gravitational waves when they violently merge. From the first groundbreaking image of M87's shadowy silhouette to the elusive Sagittarius A at our own galaxy's core, black holes continue to challenge our understanding of the cosmos, hinting at mysteries that lie beyond the reach of light. On number 7, it's consciousness. Consciousness, that elusive spark of awareness, is arguably the most profound mystery we face, a vibrant tapestry woven from our subjective experiences, our very sense of self. It's the feeling of sunshine on your skin, the unique taste of your morning coffee, the swirling thoughts within your mind, all those qualia that defy easy explanation. For centuries, philosophers have grappled with how this inner world arises from the physical brain, leading to the hard problem that still challenges neuroscientists today. Yet, research continues to peel back the layers, seeking the neural fingerprints of awareness in the intricate dance of brain regions and electrical signals. While no single answer has emerged, from integrated information theories to global workspace models, the quest to understand consciousness is a thrilling journey into the very essence of what it means to be alive and to perceive the world around us. On number 8 is Earth's life. Imagine our Earth, nestled perfectly in the cosmic dance around the sun, not too close to scorch, not too far to freeze. A true Goldilocks sweet spot where liquid water, the very elixir of life, flows freely. But it's not just our prime real estate. A majestic protective atmosphere acts as Earth's invisible shield, breathing life with oxygen and carbon dioxide while deflecting harmful cosmic rays. Deep within, a swirling molten core generates a mighty magnetic field, a force field safeguarding our precious atmosphere from the sun's fiery breath. Down on the surface, restless tectonic plates ceaselessly reshape continents, cycling vital nutrients and regulating our planet's climate over eons. Add to this the very ingredients of life: carbon, hydrogen, oxygen, and more. Abundant and ready to form the complex molecules that underpin every living thing, all energized by the consistent warmth of our sun. Even our surprisingly large moon plays a crucial role, tirelessly stabilizing Earth's tilt, ensuring the long-term climate stability essential for life's flourishing. It's this extraordinary symphony of cosmic circumstance, geological dynamism, and chemical abundance that has woven the tapestry of life on Earth, making our blue marble a vibrant oasis in the vast, cold expanse of space. On number 9 is dark matter. The cosmos holds a profound secret, an invisible scaffolding called dark matter, accounting for a staggering 85% of the universe's mass, yet remaining entirely unseen. This enigmatic substance doesn't interact with light, making it a ghost in the machine, detectable only through its powerful gravitational influence. From the dizzying speeds of stars and galaxies that should otherwise fly apart to the colossal cosmic webs connecting clusters, dark matter's gravitational embrace is the unseen hand shaping the universe. Scientists are on a relentless quest to unveil its true nature. From deep underground labs hoping to catch a fleeting interaction with hypothetical particles like WIMPs, to peering at the distant echoes of the Big Bang, all in the hope of finally bringing this cosmic phantom into the light and completing our understanding of the universe. And now, on number 10th, are we alone? Are we alone in the vast cosmic ocean? This profound question, a cornerstone of human curiosity, still echoes unanswered. Yet the whispers from the universe increasingly suggest a resounding, probably not. Imagine a cosmos teeming with trillions of galaxies, each home to billions of stars, many cradling their own planetary families. The sheer immensity makes it statistically improbable that our blue marble is the sole beacon of life. The very building blocks of life, from carbon to water, dance across the universe, and we're constantly discovering exoplanets nestled in their stars' habitable zones, places where liquid water, the elixir of life, could flow. While the famous Fermi paradox still teases us with, "Where is everybody?" Despite the high odds of life, perhaps the answer lies in the fleeting nature of civilizations, our current technological limitations, or even a cosmic game of hide and seek. Yet, the persistent hum of our radio telescopes through SETI projects and the probing eyes of telescopes like the James Webb Space Telescope searching for telltale biosignatures in distant atmospheres paint a vivid picture. The search for life, whether simple or intelligent, continues with unwavering hope, steadily peeling back the layers of our cosmic solitude. Thanks for sticking around. If you enjoyed this, make sure to subscribe. Hit that like button and share it with your friends. Your support means the world to us. Let's keep this journey going together.